11. So you can see from the figure they're saying that what ABCD is a pentagon. Okay, so pentagon means a diagram or a geometrical figure with 5 sides. So let's see. First, 1, right, 2, 3, 4 and 5. Okay, so that makes the pentagon here in this question. All right, next, a line through B. Okay, so from here a line through B parallel to AC. So you can see that this and this, right, parallel to AC meets DC, and from here it has been produced till F. All right, so that gives us the entire questions diagram. All right, we have to prove that what ACB equals ACF and also AEDF should be equal to ABCDE. So we'll do one after the other. So once again, a pentagon ABCDE. All right, and then BF, we already know the question is given to us, right? This is parallel to this AC. They are parallel, right? Okay, now let's try to prove the first. So we're going to prove what ACB equals ACF. Right, now let us look at ACB. When you look at ACB, this is the one, right? ACB. And then when you look at ACF, again ACF, can you see that they have the same base? This becomes the same base, right? And they're also between the same parallel. You can see here, which means, can I say that the areas are equal? We can say. All right, so that is where we'll get our first proof, because they are between the same base and between the same parallel. Right, now let's try to prove the second. Okay, so in order to prove this, we'll have a look at this area of AEDF. Right, AEDF, if you look, AEDF, so we can see that is this much. Right, so here can we say that it is made of two parts? The first part is AEDC, right, AEDC plus this triangle ACF. We can say, right, that they are made of two parts. This AEDF is made of two parts. They are AEDC and ACF. But now if you look at the first equation that we got, we have already proved that ACF equals ACB, which means in place of ACF, can I write ACB? We can write, right? So that is what we have done here. Now if you look once again, all right, if you look here, then what, when you look at AEDC, right, AEDC, this is a part, and then plus area of ACB, ACB, which means this part. Do I get the entire pentagon? ABCDE, we get, right, ABCDE. Okay, so that is our second proof that we're asked to prove. Alright, we'll do one last question. So you can see from here in figure, they've given us that AP, this is parallel to BQ. Again, they're all parallel to one another. Okay, so we also prove that area of AQC is equal to area of BPR. Okay, AQC means this part, right? AQC, this area is equal to this BR. Okay, that is what we're asked to prove. So let's go one after the other. Then now write on the given to prove, write it down. Okay, now let us look at the top part here. When you look at this triangle ABQ, this ABQ and then BBQ, can you see that they have the same base? They have the same base and they're also between the same parallels here, right? Which means we can say that these two areas are equal. So that will be our equation 1. And once again, when you look here below here again, okay, can we say that CBQ, when you look here, this triangle CBQ and also this triangle RBQ, once again, can we say that they have the same base? The same base is BQ and they're between the same parallels once again, that which means the areas also should be equal. Alright, so that is what we have written in equation 2. Now let us add this equation 1 and 2, which means add the left hand side and left hand side. So I've written here, and then add the right hand side and the right hand side, which we have written here. Okay, now if you look here, ABQ is this region, right, plus CQB. If you look, CBQ. So when you add these two, do we get, when we add these two areas, do we get the entire AQC? We get it, right? Now once again, same thing with the on the right hand side. Okay, BBQ, right? So BBQ is this area plus R QB, right? So RQB, that means if we take it will be this again. So you can see that there are two triangles again, which means we get the entire area, which is, if you look, it will be this BR, okay, which is our proof that we were trying to get, we were trying to solve.